Okay, good morning class. So today we're looking at the second half of the revision exercise of the trigonometry, followed by the homework I gave you for yesterday, or homework for today. So we started the revision exercise and we must carry on for question 7.2, correct? As you can see here, in 7.2 they ask you to simplify without the use of a calculator only. So 210 is in the second quadrant, so it's 1 over root 3. The third quadrant, sorry, so it will be cos 180 plus 30 plus 210. That's going to be 180 minus 45 times cos squared 180 minus 45 minus sine. Of course, 25 is not a 25 is not a special angle, so I know somehow or other 115 has to be connected to 25 somehow or other. Okay, so that can be written as cos 90 plus 25. You could have said 180 minus 65 within these, no? I could have said 180 minus 65, but in that case I'm not linking 25 directly to it. Okay, otherwise in the next step you must again convert it to its correlation. Okay. Again, this is not needed, but I do it so that we don't make the mistake on our side. Okay. So 180 plus is in the third quadrant, cos is negative, so it's negative 1 over root 3 cos of 30. 180 minus, that's in the second quadrant, tan is negative, so it's negative 2 tan 45 times cos squared. So that second quadrant, it's going to be negative, cos is negative in the second quadrant, because of the squared remains positive, cos squared 45 minus sine 25 over cos 90 plus in the second quadrant, cos is negative, although it changes to sine. Okay, cos is negative in that quadrant. This here, which is negative, will now change to a positive because of sine 25. Okay, so that's getting me 1 over root 3. Remember, this is without the use of a calculator, so we need the special angle, so it's 1 to root 3. At this point I think you should know the special angles now. Well, I hope you know the special angles at this point. So it's times root 3 over 2 minus 2. Tan is 1 over 1. Cos 45 is 1 over root 2 squared plus that cancels, gives you 1. Which now gives us root 3 times root 3, so it's negative half, minus this here, 1 squared is 1, 2 squared, root 2 squared is 2. Then that, a half times 2 is 1. So it's minus 1 plus 1. Gives you an answer of negative. Is that correct? Huh? Yes? Let's look at the next one. So I'm still bring the thing down. Number 8. The question says solve the following equations. So we go reference. Theta plus 20 equals arc sine of 0.5, arc sine of 0.577 gives me a reference angle of 35.24. Okay, so this tells us that x is in the first to fourth quadrant. Okay, so what I normally do is I do general solution first. Okay, you don't have to. I'll just do it that way, so that we practice general solution at the same time as well. So the question we must ask ourselves, in which part is sine positive? Sine positive in 1 and 2. So let's go with quadrant 1. So that would be theta plus 20 equals 35,24 plus k times 360. Okay, you take a 20 over, theta is equal to 15,24 plus k times 360. Okay, so for quadrant 2 is theta plus 20 equals 180 minus 35,24 plus k times 360. The theta works out to be 180 minus 35,24 minus 20 is what? 130 something. Should be no 80 120 something. Yes, 120 4,76 plus k times 360. Where k is an element of integers. If it was general solution, you stop here and you say k is an element of integers. But we are given as restricted value, a restricted domain here. So we start with k is equal to 0, so that falls away. So therefore theta is an element of, you put 0 in here and we get 15,24 degrees. Put 1 in is going to be over 360, put negative 1 in is under 360. And the 0 is negative. So that doesn't work. Same story there. K is 0, you get 124,76. You must get a general solution sum in every exam. Minimum of 6 marks. Okay? So now to do general solution. The next one is 8.2. Again, you have a restricted domain scenario here. So first things first, I divide by 2. So sine 2 theta is equal to negative root 3, and I then divide by 2. They could have asked you this question without to use a calculator, because why, this is a special angle. As you can see here, your 2 theta is going to be 60. I drop the sign, so I say reference 2 theta is equal to 60 degrees. If you're not, you didn't memorize the ratios, you could have checked. Arc sine of root 3 over 2. Remember, at this point, we do not use a negative. We have a positive outlook on life, so we work with positive angles. Okay. So, the question that should come to mind at this point is which quadrant is sine negative? And in which quadrant is sine negative? Sine is negative in quadrant 3 and 4. So let's go with quadrant 3. Remember, at this point we don't divide by 2 to get theta and 0. We only divide by 2 once you have taken it into its necessary quadrants. Okay. So in quadrant 3, it's going to be 2 theta equals, quadrant 3 is 180 plus 60 plus k times 360. Not so? 180 plus 60 is 240, divided by 2 is 120. So it's 120 plus k times 360 divided by 2 is 180. For quadrant 4, how do we get in quadrant 4? How do we get in quadrant 4, people? 360 minus 60 plus k times 360. 360 minus 60 is 300 divided by 2 is 150 plus k times 180. Okay. Remember, there's a restricted domain. So where do I start? I say, okay, theta is in an element of. If I put 0 through here, through the first one, I'm going to get 120, which is inside this domain. Okay, so 120 degrees. If I put k to be 1, then I'm going to get 300 degrees. Okay? If I put k to be minus 1, then I get negative 60 degrees, which is still inside. If k is minus 2, then it's negative 240, which is outside. We try this branch here. Put 0 through k, I get 150 degrees. Put 1 through there for k, so they give you 330 degrees outside. Put negative 1 in, I get negative 30 degrees. Negative 2 in, I'm not going to, I'm going to be another angle outside. So there's my domain, oh my values for theta, for which theta exists between that given domain. Okay, you guys understand? Okay, let's look at the next one. This is find the general solution. So if you look at this here, we'll see we've got the sine squared and we've got the cos. So we're rather going to change the sine squared to a cos squared. Okay? And form a trinomial. You can't change the cos to a sine. Otherwise it's going to be cos sine of 90 minus theta. There's nothing you can do with it. We must have the sine squared or the cos squared in terms, the angles must be the same. You are going to do any type of factorization on that. Okay. So what happens is, we're going to change sine. So we know that sine squared theta plus cos squared theta is equal to 1. So that means to say that sine squared theta is equal to 1 minus cos squared theta. Not so. Sine squared theta is going to be 1 minus cos squared theta. So what we do is we say, okay, you got 3 cos theta plus 3 equals 4 into 1 minus cos squared theta. Multiply that in, I get 0 is equal to 4 minus 4 cos squared theta minus 3 cos theta minus 3. So it's going to be negative 4 cos squared theta minus 3 cos theta plus 1. Now you can divide by negative, factorize, use the quadratic formula, any of the above. So I go negative 4, there's a quarter and 1, negative 3 and 1 is negative, it's a quarter. So cos of theta is a quarter, or cos of theta is equal to negative 1. Okay. So now again, general solution for cos of theta equals a quarter. Let's go with that. So for this one here, my reference, theta is equal to arc cos of a quarter. Oh, okay, plus 3. Arc cos of a quarter gives us 75,52. Okay, so which quadrant is cos positive? 1 and 4. So theta is equal to 75. 52 plus k times 360. So that's going to happen every 360 times. At this point, I could have said theta is equal to plus minus 75,52 plus k times 360 because that's in the fourth quadrant. But we don't answer like that. We answer with positive numbers. So how do we get into the fourth quadrant? 360 minus. So 360 minus 75,52 gives us 284,48 plus k times 360. Now sometimes the textbook gives the answer of a negative 75,52 plus k times 360. To check if you are correct, you add whatever value is here, k times whatever value, in this case is 360. You say negative 75,52 plus 360, it gives you that answer that you have. Okay. If you work with a negative angle and they gave you this obtuse angle, the reflex angle here, and then you just say that minus 360 should give you that angle there. Oh, you got it. Okay. So that takes care of that one. Let's look at the side here. So now we're going to look at sine cos of minus 1. So that takes you to the cos graph. The cos graph starts at the top and does that. Cos of minus 1 is equal to 180 degrees. Can you see that, people? It's only one point on the cos graph that is negative 1. So what can I say? Therefore, theta is equal to 180 plus k times 360. So that solution is actually giving 360 degrees. And again, why do we say k plus 360? Because the period on the cos graph is 360. Any confusion here, people, before I take it off? No? 8.4. Again, tan of theta plus 40 is equal to tan of 52 for the theta is greater than negative 360 but less than 360. Again, people, arctan of 52 is 52. So my reference angle here of theta plus 40 is 52 degrees. Okay. Again, you don't have to go into general solution, but we practice it at this point as well. So in which quadrant is tan positive? This tan now is positive in quadrant 1 and okay, so how do we get in quadrant 1? It's going to be theta plus 40 is equal to 52 plus k times 180. Not so. So it's k times 180 then. So k times 180. So we take it over, it becomes theta equals 52 minus 40 is going to be 12 degrees plus k times 180. Not so. Now you can go into quadrant 3 as well, but your tan will have a repeated solution. Okay? So for tan we just write it in one, write the branch out once. But if you don't remember that or you're not sure and all of those things, you write. For quadrant 3 is going to be 52 plus 180, sorry, plus 52 plus k times 180. You write it out both if you don't know when to leave it out. Okay? But in this case we're going to leave it out because with tan has a repeated solution. So remember that was the restricted domain for the graph. So therefore theta is an element of. So we go 1, put 1 into k. Sorry, 0. I get 12 degrees. If I put 1 in, I get 192 degrees. Correct? Put another 1 in, which is 2. So what I do is I say 12 plus 2 times 180. You get 372, which means to say it's outside the given domain of 360. Beyond that. There you go, minus 1. It's negative 168, which is inside. Put negative 2 in. Negative 348, which is also inside. If I'm going to put the next number in, of course, it's going to be outside. Okay. Some nuggets normally worth 5 marks. Okay. And then the next one, again we need the space. The last one. So you have sine of theta minus 20 is equal to cos of 3 theta. Find general solution. Again, this is not going to work for us. That's all. You can't say arc sine or arc cos or whatever at this point. However, we know that this can be sine of theta minus 2. If I could let this be sine, then I can just drop the signs. So there you go, sine Sine of what? 90 minus 3 theta. There you go, see, you got both signs. So what do I say now? Reference, theta minus 20 is equal to 90 minus 3 theta. So what question comes to mind? In which quadrant is sine? Positive. Not so. In which quadrant is sine positive? First and second. So let's go with quadrant 1. It's going to be just theta minus 20 is equal to 90 minus 3 theta plus k times 360. Not so. So we solve for theta here, we take that over and this is that way. So they give then 4 theta is equal to 90 plus 20 is 110 plus k times 360. Divided by 4, so theta is equal to, divided by 4, 110 is 55. 55 divided by 4 is 54, 27.5. No? 27.5 degrees plus k times 90. Okay, so that's quadrant 1. And let's go with quadrant 2. Are you getting quadrant 2? Is it right again? Quadrant 2 is going to be theta minus 20 equals 180 minus 90 minus 3 theta plus k times 360. Why? The period on the sine graph is 360. Here are the brackets. So theta minus 20 is equal to 180 minus 90 plus 30. Or 3 theta, sorry, plus k times 360. You take it over, becomes negative 2 theta. 180 minus 90 is 90 plus 20 is 110 plus k times 360. Divided by negative 2, so 150 divided by negative 2 is negative 55 degrees plus k times 180, where k is an element of. Alright, so that basically brings us to the end of our revision exercise. Okay. Then you guys had homework for today, and the homework was on, what was it? So this exercise we're busy with. 2, no? On page 95. So yesterday we've done all the odd numbers. We did 1.1, 1.3, 2.1, 2.3, 2.5, 2.7. Okay? No? Is that correct? Then you add for homework 1.2, 1.4 and the even numbers of number 1 and 2. No? Any problems with number 1? Huh? Number 2? 2.6, 2.8. Two 2.8. The question says, rewrite the expression that follow as the sine or cosine of a single angle and evaluate where possible without a calculator. Okay. So, what do we see here? I see a sine alpha cos beta plus cos alpha sine beta. Which rule is this? Which rule is this, people? Sine rule. You all have a formula sheet. Who doesn't have a formula sheet? For your formula sheet didn't see a light of day now, no? Since last year. A mistake, no? When it fell out of your book. Yeah, come fetch one. You don't have a formula sheet? Please come fetch one. And don't come fetch for your neighbor and all of those people. No? So I can see who doesn't look after this stuff. Now fetch one if you need one. You'll see on the formula sheet. You see that formula is there. At the bottom of the formula sheet, there are the sine formulas. Sine compound, cos compound. No? So which formula is this? This is going to be sine alpha plus beta. You all agree with that? So this here, you've got alpha, so this is sine alpha plus beta. No? So what's my alpha angle here? 90 minus x. What's my beta angle? X. Can you see that? That cancels. So it's going to be sine 90. So if we take sine 90 to the graph, what is sine of 90? 1. Answer is 1. Who asked this question? You understand?
Yes, sir. I think the textbook answer was something else.
What's the answer in the textbook?
Cos 2x.
Cos 2x. Sorry? Yeah, the sign must be the same. Because it's the sine rule. Otherwise, if we change this, let's just check something. If we change this, that can be written as cos x, cos x, not so, plus sine is actually minus sine x, sine x. So that's going to give you cos squared x minus sine squared x, not so. Yes?
So for the second...
Oh yes, cos. So we could have used the cos rule, cos rule. No? So it will become cos x plus x, which is cos 2x. But cos 2x is not 1. (90 minus x) is cos x. Oh no, we are wrong. What's our mistake? That answer is correct, no? What's our mistake? I assume that there, which is alpha, and that is the same. It's not the same. If that had to be 90 minus x, and the second bracket had to be 90 minus x as well, then I could have applied this. Not so? It's not the same, so you can't apply it. There's a good sum, the quota's out. I like it. So like that, they are right, no? Yeah. Nice. Did you also think that was 90 minus x? Huh? Did you not know it's 90 minus x? You knew it was, one was 90 minus x and one was 90 plus x. You knew it. Then you can't apply that rule. Not so? Because that angle, that angle here, alpha, must be exactly the same angle there. Okay, now at least we highlighted something. Okay, it must be exactly the same. Can't be different. Okay. Thank you. Any other comment on that question? Sorry?
No, sir.
No comment. Okay, it sounded like somebody was saying something. Alright, let's go to the next one. The next one says cos 45. So there's the alpha. Sine beta. So can I get a 45 here? That's cos 45. Sine 75. Plus, how can I get the 45 here? 180 minus. But this is sine, cos, cos, sine. No? Sine, cos. You say sine, cos. So this is going to be, how can I get a 45, either 45 or 75? What are we going to get here? 45. So how can you get, what are we going to get here? It's going to be sine 90 plus 45. Not so? Or I could have said 180 minus 45. We'll see now which one is correct. How can I get the 75 here? 90 minus again. Not so? Sine 90 minus 70. Why am I writing it like that? So that this is going to give us sine cos, cos sine. That's what I want. Okay? So that's simply going to give us sine 75, cos 45. 90 minus first quadrant, sine is positive. So it's positive sine 75. No, cos, sorry. 90 minus, change to cos times 90 plus, that's in your second quadrant. Sine changes to cos 45. But yes, cos, cos, that's a problem. Not so? What do I need this to be? I need to be a sine. So in other words, this I had to choose sine 180 minus 45. Or you could have changed that afterwards by saying 90 minus 45 is going to give you cos 45. Either way would be correct, okay? Which now gives us sine 45. So let's go now. Sine alpha, cos beta, which is now cos alpha sine beta. Is that not the one of our identities? Yes, it's the one on the board. Not so? So this would simply be sine alpha, which is 75 plus what? 45. And what's 75 plus 45? 120. Is that a special angle? Yes, can be reduced. Can be reduced to what? Sine 180 minus 60. That's the second quadrant. Sine positive or negative? Positive. So it's going to be sine 60. So that takes us to the special angle. Triangle. So that is 30. 60. 1, 2, root 3. So sine is opposite over hypotenuse. So it's root 3 over. Okay. Is that correct?
Yes, sir.
Good. Then at this point you had to do the odd numbers of number. Did we do the odd numbers of number 3 yesterday? Yes, so you had to do the even numbers of number 3 as well. Yes, any issues there? 3.6, 3.10, okay. People, it's a very, very important exercise to know how to do, okay. This is exercise 2, page 95. Okay. So again, it's an identity. You must prove the following identities. As you can see, the left-hand side is more complex. The sine expansion is being multiplied by another sine expansion. That's going to be sine of alpha cos beta plus sine beta cos alpha, or cos A sine B. Okay, you multiply it by sine alpha cos beta minus sine beta cos alpha. So what do we notice? The conjugate pair, not so? This is the same as saying x plus y times x plus y, x minus y. Multiply the first and the last, gives you x squared minus y squared. Not so? So here the same story. Multiply the first and the last. So now it gives us sine squared A, I think I did something like this yesterday, cos squared B, minus sine squared B, cos squared A. So what do you notice? They want the cos squared B, so this one I'll keep, and they want cos squared A. Let's keep, just change the signs. Okay? So we know that sine squared A plus cos squared A is 1, sine squared B plus cos squared B is 1. Okay, so I'm going to replace that with 1 minus cos squared A times cos squared B minus 1 minus cos squared B times cos squared A. So you multiply this out, I get cos squared B minus cos squared A cos squared B minus cos squared A plus cos squared A sine cos squared B. Okay, so you see here, negative cos squared A cos squared B cancels cos squared A cos squared B. So that would simply be cos squared B minus cos squared A, which is equal to the right hand side. Okay. Next one. That is now your left hand side story here. So that would simply be cos alpha cos beta minus sine alpha sine beta. And that minus is this minus, so I must have a bracket there. Sine A cos B. This is now your alpha and beta now, no? Minus sine B cos A. Okay. So for the 45-degree angle, I'm going to take it to the special triangle there. So cos of A, cos of 45 is 1 over root 2. Cos of A. We always write the coefficient in front. Minus, that's 1 over root 2. Sine of A. I'm going to multiply that out, gives me a negative. Cos 45 is 1 over root 2. Sine of A. That then gives us positive. Sine 45 is 1 over root 2 cos A. Look for like terms. So this one here, and that one is like terms, not so? So it's going to give you 2 over root 2 cos A, which we have there. That should be positive. Why is that positive? Because that is negative. So that will cancel. Leave you with that, which is equal to your right hand side. Okay. Sorry about that there. Then you had to, the day before yesterday, you had to do the even numbers or the odd numbers of number 5. Not so? Huh? Yes? No, number 4 first, no? It's number 4. It says find the value of the ratios in terms of root 3, root 2 using the sum of the difference of two special angles. So there. Okay. So the first one is cos 15. Which special angles makes up 15? It's going to be 45 minus the, or I could have said 60 minus 45. It's the same. It'll also give you 15. So cos, the cos expansion is cos alpha, cos beta, opposite side, sine alpha, sine beta. Okay, cos 45, again take it to the special angle, see? So it's 1 root 2, 30, so 1 2 root 3. So cos of 45 is 1 over root 2 times the root 3 over 2 plus sine 45 is 1 over root 2 times 1 over 2. So that gives us root 3 over 2 root 2 plus 1 over 2 root 2. Denominators are the same, so you can add the numerators. So it's going to be root 3 plus 1. Okay, is that correct? Right? Look at the next one. Just take this away. (105). Which special angles make up 105? 60 plus 45. Cos, so it's going to be cos 60, cos 45, opposite side, sine 60, sine 45. Which now simply gives us 1 over 2 times 1 over root 2 minus root 3 over 2 times 1 over root 2. Which gives us 1 over 2 root 2 minus root 3 over 2 root 2, which is 2 root 2, denominators are the same. Okay? The next one, I must first reduce. Alright. Use the reduction formula, so this can be written as sine 180 minus 15. Not so? It's in the second quadrant, sine is positive, so sine 50. Okay? So the sine expanded, the special angles here that could be used is going to be 60 minus 45. 60 degree triangle is 1 2 root 3. For 45 is 1 root 2. So that would be sine alpha cos beta minus sine beta cos alpha. That now gives us 1 over 2, no, root 3 over 2 times 1 over root 2 minus 1 over root 2 times a half. So that will be root 3 over 2 root 2 minus 1 over 2 root 2, which is root 3 minus 1 over 2 root 2. Okay. Then number 5, what is an, did I say 1.6 as well? No. 4.6 is for tomorrow. Okay, all the even numbers, of course, is for tomorrow. People number, exercise 2, page 95. It says use the ratio to draw diagrams in the Cartesian plane. First find the individual ratio and then calculate the ratio of a compound angle. Do not solve the angles with the calculator. So, what we have here is sine alpha. Sine alpha, this means to say sine is positive. And we are told that, so which quadrant is sine positive? 1 and 2. Then we are told it's acute. If it says acute, what does that mean? First quadrant. So we're going to draw this in the first quadrant. Here's your alpha. What does sine stand for? Opposite over hypotenuse. Apply Pythagoras, I get 3 here. It will be positive part of your x-axis. So that, if they talk about alpha, they're talking about this diagram. Okay. Then, this part of the question, sine of beta, which quadrant is cos of beta, which quadrant is cos negative? 2 and 3. Not so. But beta is greater than 0 but less than 180. So that is quadrant 1 or 2. So which quadrant are we drawing in? Quadrant 2. And there's your beta angle. Even if this had to be in the same quadrant, both had to be in quadrant 1, you must still draw different diagrams. So the angle is different. Okay? What does cos stand for? Adjacent over hypotenuse. So there is 12, hypotenuse is 30. Where does the negative belong to the 12 or the 30? The 12. The hypotenuse is never negative. Okay? And the radius as well. If I apply Pythagoras, what am I going to get there? I'll tell you it's 5. Okay? You apply Pythagoras. Can you see that, people? So now coming back to the equation. Whoops. The question was, must evaluate or determine or calculate what cos of beta minus alpha is. Now, can I use beta minus alpha in this diagram? No. We have a beta angle and we have an alpha angle. So what does cos beta minus alpha stand for? It's going to be cos, so it's cos beta, cos alpha minus, no plus, sine beta, sine alpha. Remember now, this is your alpha and your beta according to our normal, what's the name, formula. But now they swapped it around, okay? We don't swap it around, we use it as it is, okay? You all okay with that? Is anybody confused at this point? Okay? So what does cos beta stand for? Cos is adjacent of hypotenuse. So it's negative 12 over 13 times cos of alpha. What does cos stand for? Adjacent of hypotenuse. But now we're busy with the alpha angle. So it's 3 over 5. Plus sine of beta. Sine is, again, I can only use this angle if we're talking about beta. Sine is 5 over 30 times sine of A, sine of alpha. Suppose it had been alpha, no? Sine of alpha. If I use this diagram now, sine is opposite, which is 4 over. Okay. So what I do from here, punch it in the calculator. So I say negative 12 over 13 times 3 over 5. Plus 20 over 65. Okay. Why could I just say 4 over 13? I get negative 16 over 65. Is that correct? Yes. Okay. Any problems here? Any questions? Any confusion here? Can you guys do this now? Okay, I know you didn't do one like this. Or did you have one like this last year in your exam? Not now the compound angles, but the two in one. Did you have a 2 in 1 last year? Oh my word, I'm talking to this. You didn't. You sure? Okay. You didn't do last year's homework then. Because it comes out of the clever maths, the textbook we used last year. Go through the textbook, you'll see there's one of those. We have 2 in 1. In one side. We have to do 2 diagonals. But anyway, it's fine. People, tan of A. Which quadrant is tan positive? Quadrant 1 and 3. But what does this tell us? It has to be, A has to be greater than 90. So it's quadrant 2, 3 and 4. So which quadrant are we going to draw that in? Quadrant 3. So there's my angle. Tan is opposite over adjacent. No? So that's going to be negative 3, negative 4. That's going to work out to be 5 according to Pythagoras. This one here, however, a tan of B. So the beta angle. In which quadrant is tan positive? 1 and 3. But beta is less than 90. So it's 1. So we draw this angle in the first quadrant. Tan is opposite over adjacent. So it's 5 over 12. Apply Pythagoras again. 13. This is called the Pythagorean triple. Okay? I'm not working this out in my head every time. It's your angle. So now the first question is, what is cos of A plus B? So that's going to be cos A cos B minus sine A sine B. So cos A is negative 4 over 5 times cos B is 12 over 30 minus sine A is negative 3 over 5. Sine B is 5 over 30. Somebody give us the answer to this. Negative 33 over 65. Then sine A plus B is going to give you sine A cos B plus sine B cos A. So sine A is negative 3 over 5. Cos B is 12 over 13 plus sine B is 5 over 13. Cos A is negative 4 over 5. That gives us an answer of, sorry, negative 36 over 56. 56 divided by 65. Okay. Now coming to question 5.3.3. We don't have a tan compound angle, not some, but we know that tan A plus B, but tan isn't tan sine over cos. So it's sine A plus B over cos A plus B. Can you see that? But sine A plus B we worked out to be 56 over 65 divided by cos of B, which is negative 33 over 65. Which gives us an answer of 56 over 33. Okay. Is that right? Okay. People, enjoy the rest of your day. Don't forget your homework is going to be the even numbers. And revise this exercise for tomorrow's lesson. Very important. Tomorrow we're going to do compound angles. People, enjoy the rest of your day. Good morning, class.